what is the smallest positive integer for which, when we multiply it with 540, we get a perfect square? This is an example of a question 17 type of difficulty on an AMC8. But it's also a nice problem about number theory. Number theory, because we're talking about perfect square. Perfect square means it's like 49, 7 times 7, or like 64, 8 times 8. How do you do this? I don't recommend just trying to multiply by integers. Don't try to do 1 times 540, doesn't work. 2 times 540, doesn't work. No, I don't recommend doing this, because this kind of question is one where there should be a good method. For example, when you look at this, maybe you're familiar with what happens to zeros at the end of perfect squares. Most perfect squares that end in 0 have more zeros. Not most, all. And that's because in order to end in 0, it's something that ends in 0 squared. So maybe you might even think that the first thing to try is to take 540 times 10, to do 5,400. But what I want to say is that that's actually not the right way to go. And the way to see that is to talk a little bit about prime factorization. The best way to do this kind of question is to think that perfect squares come when every prime factor comes the right number of times. Let me show you. So let's prime factorize 540. I see a 2. If I take a 2 out, I have 270. If I see another 2 because it's even, 135. I see a 5 very easily because it ends with a 5. 5 times 2 is 10. Here's a 7. I know what 7 is. 7 is 3 times 3 times 3. So I'll take, 27 is 3 times 3 times 3. Take them all out. And what I have now, I see I have 2 squared times 3 cubed times 5 to the first power. There are different ways to do this. Maybe I'll share another way that sometimes I do this just to double check. Another way I sometimes do this to double check is I will just say 540 I recognize is 54 times 10. Now 54 I know is 6 times 9. 10 is 2 times 5. 6 is 2 times 3. 9 is 3 times 3. And now I look and I see if I have the right number of primes. 2 2s, 3 3s, and a 5. 2 different ways. Whenever you do a question, if you can do everything in 2 ways quickly, then you will make sure you don't have a mistake. But now, I'm actually interested in taking this number, 540, and multiplying it by something else. And my goal is to make a perfect square. Square means something to the power 2. Actually, if I have any perfect square, I will need to have the powers of the primes to all be even. And once you make that observation, you say 2 squared is already even. The power is already even. 3 cubed needs another 3. 5 to the first needs another 5. And so if I multiply by 3 times 5, then I will get a perfect square. And that's also the smallest one that I can use, because I have to multiply by a 3 to make an even power of 3, and I have to multiply by a 5 to make an even power of 5. So this is the smallest thing that you can use, 15, in order to take 540 and multiply it by a number and make a perfect square. The question actually had a second question. How about a perfect cube? What if I want to have the result be something cubed? The same idea works. The same idea is that now I need that when I multiply, all of these exponents are multiples of 3. So let's just finish that off. If I have 2 squared times 3 cubed times 5 to the first, what do I need to multiply it by to get a perfect cube? I need another 2, and I also need 2 more 5s. 2 times 5 squared is 50. So this question is a little bit of a joke in some sense. If I want to take 540 and multiply it by something to get a perfect square, it's 15. And if I want to get a perfect cube, it's 50. 15, 50. They sound similar. It's actually quite a nice coincidence. Actually, in Chinese, 15 50. How nice. Math has a lot of these interesting coincidences when you get to know the numbers. Number theory is about making friends with all of these whole numbers and integers so that you recognize patterns. And in the end, you can find nice surprises, like what it takes to multiply by 540 to get a perfect square or a perfect cube.